All right, last one. Let's find the inverse of this square root function. We know that the square root function will pass the horizontal line test. If we're unsure, you could graph it and take a look at it, but it certainly will. So let's go ahead and find the inverse. Y equals square root of 2x minus 3. Switch them. X equals square root of 2y minus 3. And let's get y out all by itself. So we need to square both sides. We need to add 3. And we need to divide by 2 to get our inverse function. Now there is one thing that we have to keep in mind. When we do an inverse, we switch the range and the domain. So when we started, this is a square root function, taken off like that. It's actually shifted over, sorry. Shifted over by 1.5. But the range here is y has got to be greater than or equal to 0. We are never going to have negatives, and we know that because you can't have negatives under the square root. When we switch to find the inverse, the domain is going to be exactly the same as the range when we started. If we said y is greater than or equal to 0, now x has to be greater than or equal to 0. So we would need to include that restraint. Otherwise, we would get a parabola, x squared, and a parabola is no good because it doesn't pass the horizontal line test. So this is saying we only want half of it, just the positive side, greater than or equal to 0. Go ahead and try your last example, 69. All right, does this have an inverse? If we did not have this restraint, it would not pass the horizontal line test. This is a parabola, shifted left 3. It would normally look like that. But since we say x has got to be greater than or equal to -3, we lose that whole part. And so it's just going this way. That passes the horizontal line test. It does indeed have an inverse. Let's find out what it is. Y equals x plus 3 squared. Let's switch them. So to get the squared out of there, we're going to square root. And so the square root of x minus 3 would equal y. And again, when we finish, we should write that in function notation as f inverse of x. All right, that's it for section 1-9.